Okay, so for the new material for class 5, the first thing we're going to do is a hypothesis test for a population proportion. Let me start with the two-tailed test. This is just like we did with means. Suppose we have a null hypothesis that the population mean is equal to some amount. Okay, suppose you might say the percentage of people who support Donald Trump is 44%. And I say, well, I don't think you're doing great research, whatever. I just want to, or maybe I'm just doing this as an exercise. I'm not trying to get into an argument with you. I'm just trying to find evidence and quantify how I'm making this decision. So I set up an alternative hypothesis that the population proportion is not equal to that amount that you say. Again, looking for overwhelming evidence in the upper tail or the lower tail. Similarly, I could say the population proportion is less than some amount, like less than 30%. I think less than 30% of people would support this change. Alternative hypothesis would be more than 30% of people would support this change. We could do a hypothesis in the up, just the different tail hypothesis, a different one tail hypothesis. You might say null hypothesis. I think less than 15% of students at Mercy College live on campus. Actually, it'd be pretty easy to get the exact numbers, so maybe that's not a good that's not a good example. So I think less than 15% of students at Mercy College are baseball fans. And the alternative would be that more than 15% are baseball fans. So we would set up a one-tailed test to test this proportion, this population proportion. We would use the same thing we use for means, testing means, and the same thing we've used for a number of classes, the sampling distribution of sample proportions. This is this wonderful normal distribution. It is a frequency distribution of all the sample proportions. We know that this is normal, and because it's normal, we know where the data lies in terms of how far above and below the mean it is. And if we use good sampling procedures and we have the appropriate sample size, this distribution will be approximately normal. And recall that as long as the sample size times the population proportion is greater than or equal to 5, or the opposite, n times 1 minus the population proportion is greater than or equal to 5, then we're good. And we know two important things about this normal distribution. One, it is centered around the true population proportion, and it has a standard deviation based on the math of how close the population proportion is to 50%. If it's closer than 50%, then it's going to have a wider standard deviation. If it's more extreme, it's going to have a tighter standard deviation. So what we'll do in hypothesis testing is we will assume that your statement about 44% of people are supporting Donald Trump, we'll assume that that's true. Then we'll go out, we'll get some sample data, and we'll see if our sample data provides overwhelming evidence to the contrary. Pretty straightforward, pretty similar to what we did last time. And the way we'll calculate our test statistic for a population proportion is we will look at the difference between our sample proportion, this p with a bar above it, and the population proportion. All right, how much of a difference did we find in our sample versus what you say under the null hypothesis? We'll calculate how many standard deviations above and below the assumed mean that would be. So this is the standard deviation. If you just look on the previous slide, this is the standard deviation of the sample distribution of sample proportion. And that calculation gives us our z statistic. And then we will see All right, does this Z statistic fall in a region in which we would say that is so unlikely under the assumption that 44% of people support Donald Trump that I'm going to reject your null hypothesis and I'm going to assume the alternative hypothesis. Alright, so I actually wrote down a little start of an example here, but I think I'm going to leave it at that because we're going to do an example in a minute. So we've got Z stats, and on this next slide we've got the rejection rule. We're going to set up the critical values the same way for a population proportion. And well, let's go straight to our two-tailed test. If our null hypothesis is that the population proportion equals a certain amount, say 44% of people support Donald Trump, if the absolute value of the Z statistic we calculate is greater than the critical values we come up with based on whatever significance level we are comfortable with, then we're going to reject that null hypothesis. And we can set up a one-tailed test or two-tailed test the exact same way we set up the sample mean tests. We can reject based on whether or not this test statistic falls outside or in the rejection region. We can also use the p-value approach. We calculate the p-value the exact same way we calculated the p-value for sample means. We would calculate our test statistic. We would see on the Z-table the area under the curve associated with that test statistic. If it's a two-tailed test, we double that number and we get the p-value. If it's just a one-tailed test, we do not double that value. That value is our p-value. And if the p-value is less than our significance level, which would be our threshold for what we believe to be unlikely, then we reject the null hypothesis. Alright, let's move on to an example, or not move on, I don't want you to think we're moving too fast through this material. We're actually going to do an example which will sum up everything we just went over with the hypothesis test for proportions.